titration, acid-base titration, and how to do titration calculation. Now, what is titration? Titration is a process in which a solution of known concentration is used to determine the concentration of a known solution is called titration. For example, consider sodium hydroxide solution in HCl solution. Let the volume of sodium hydroxide taken in this object be 50 cm3 and its concentration is 0.5 m, while the volume of HCl taken in this object is 30 cm3, but its concentration is unknown. This is a solution of known concentration, it is called titrant. While this is a solution of a known concentration, it is called analyte or titrant. In titration, we use this solution of known concentration to find the concentration of this solution. This whole process is called titration. Also, you should learn about the main instruments used in titration. The primary instruments used in titration are burette and conical flask. In the burette, we take the solution of known concentration like sodium hydroxide, which is also known as titrant. While in the conical flask, we take the solution of unknown concentration, which is also known as analyte. Thus, remember that we take titrant in burette and we take analyte in conical flask. Now, what is acid-base titration? Well, a process through which the concentration of either acid or base is determined is called acid-base titration. For example, consider 30 cm3 of HCl solution in a conical flask. I take 50 cm3 of sodium hydroxide solution in the burette which has 0.5 molarity. Also, we know that acid like HCl reacts with base like sodium hydroxide to form salt plus water. So we would react acid HCl with base like sodium hydroxide. This whole process is called acid-base titration. We know that the volume of HCl is 30 cm3 and its concentration is unknown. To find the volume of titrant, sodium hydroxide used to react with analyte HCl, the initial volume of titrant was 50 cm3 and the final volume of the titrant is 30 cm3. So always subtract final volume from initial volume. I mean 50 cm3 minus 30 cm3. We get 20 cm3. What is meant by this 20 cm3? Well, this 20 cm3 means that 20 cm3 solution of sodium hydroxide reacts with 30 cm3 solution of HCl to neutralize it completely.
Now, the final step is titration calculation. I will find the concentration of HCl. Firstly, I will write the chemical reaction. Sodium hydroxide plus HCl react together to form sodium chloride plus water. We can see that this chemical reaction is already balanced. In the previous slide, we know that 30 cubic centimeters solution of HCl is used and 20 cubic centimeters of sodium hydroxide solution completely reacts with it, having 0.5 molarity. So I will write here, volume of sodium hydroxide is 20 cubic centimeters. Volume of HCl is 30 cubic centimeters. Concentration of sodium hydroxide is 0.5 m. To solve for the unknown concentration of HCl, we use the simple formula M1V1 is equal to MV. M1 is the molarity of sodium hydroxide, which is 0.5 m. V1 is the volume of sodium hydroxide, which is 20 cubic centimeters. M2 is the molarity of HCl. That's what we're trying to find. V2 is the volume of HCl, which is 30 cubic centimeters. Plugging in the numbers, we get 0.5 m multiplied by 20 cubic centimeters is equal to M2 multiplied by 30 cubic centimeters. Solving for the M2, we get M2 is equal to 0.5 m multiplied by 20 cubic centimeters over 30 cubic centimeters, which gives us an M2 of approximately 0.33 molarity.